A team of three people is to be selected from 4 men and 5 women. Find the number of different teams that can be selected with include at least 2 women. So we have 4 men, 5 women. So at least 2 women. So 2 women or 3 women out of three. So 1 man. And then this one no man. Okay. So for the first case is 4C1 times 5C2. Out of 4 men, choose one, and then out of 5 women, choose two. And this one is 5, choose three. So we have the 4C1 times 5C2 is 40. And then we have the 5C3 is 10. So total is 40 plus 10, then is 50. Yes, correct. And then next, a committee of 5 people is to be formed from 6 doctors. So we have 6 doctors, 4 dentists, 3 nurses. Find the number of different committee that could be formed if there are no restriction. So n is 6 plus 4 plus 3, then is 13. So out of 13, we choose 5. So this is 13 choose 5, then is 1, 2, 8, 7. And then the committee contain at least one doctor. So one doctor, at least one doctor, then we can have 1 doctor, 2 doctor, 3 doctor, 4 doctor, 5 doctor. Then we have 5 case. It's difficult. So what I do is we find the combination that there is no doctor. So no doctor, n is 4 plus 3, 7. So out of 7, we choose 5. So we have the 7C5 is no doctor, 21. So we have 1287 minus 21. Then it will be 1266. Okay. The committee contain all the nurses. So all the nurses, so 3 nurses included inside. So we have to choose out of 5 minus 3, we choose 2 only. And then n, we have the doctor, and then this we have the 6 plus 4, then 10. So for this one, it will be 10C2. Okay, out of 10, we choose 2. So 10C2. So 10C2. So 45. Okay. Question number 3. Find the number of ways in which 12 people can be put into 3 groups containing 3, 4, and 5 people respectively. So the first group, we have 3. So out of 12, we choose 3. Then 12 minus 3, then is 9. So out of 9, we choose 4. And then the last one, we have the 9 minus 4 is 5. Then we 5 choose 5. 5 choose 5, actually we no need to write, it's 1. So what we do is 12 choose 3. Okay, choose 3 times the 9 choose 4. Then it's 27720. Okay, so this will be the answer. 27720. Okay. Question number 4a. A 4-digit code is to be formed using 4 different numbers selected from 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1 until 9. So 1 until 9. Okay. 4-digit code. How many different codes can be formed is there's no restriction. So we have the 9P4. Okay. So this is 9P4 and it's 3024. Okay, only prime number are used. So prime number 3, 5, 7, and then 2. Okay, prime number start from 2, 2, 3, 5, 7. So we use this 4-digit to find the 4-digit code. Then it's 4P4. So this will be the 4P4, 24. Okay, and then next, two even number followed by two odd number. So even number is 2, 4, 6, 8. odd number is 13579. So this 4 digit, we have two even, then two odd. So 4354. Okay. So this is 4 times 3 times 5 times 4. So it's 240. Or we can say that this is 4p2 and this is 5p2. So we have the 4p2 times the 5p2. Then it's 240. Yes. And then the code form are even number. So 2468 here. Okay. Then out of 4. So we have 9 minus 1, 8, 7, 6. So this will be the 8 times 7 times 6 times 4. Then we have the 37184. Or what we can do here is we have the 4p1 here. And then this is 8p3. So we have the 8p3 times the 4p1. Then it's 8p3 times 4p1, then it's 1344. And then just now this one, oh, I make a mistake here. Yes, 1344. Okay, so this is 1344. And then question number 5. Find how many different 5-digit code can be formed using 1, 3, 5, 6, 8, 9. 1, 2, 3, 4, 5, 6. So we have out of 6p5. So this is 6p5. Then it's 720. And then number 2, how many are odd? So odd, 5-digit odd. So end with 1, 3, 5, and 9. So 4. So 6 minus 1, 5, 4, 3, 2. So we have the 5 times 4 times 3 times 2 times this one is 4. Then it's 480. Okay. So this one is actually 4p1 and this is the 5p4. So we have the 5p4 times the 4p1. So this is 480. Okay. Number 3, how many of these 5-digit number are odd and greater than 60,000? So odd and 60,000. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So odd. So that's mean odd. It will be 1359. Okay. And then greater than 60,000. It must start with 8, 6, 8, 9. So this is 6, 8. And then 9 here. Then we have the 135. So 2, this one is 4, and then out of 6 minus 1, then is 4 here. Okay, so 1 is the first, 1 is the last. Okay, so we have the 2 times 4 times 3 times 2 times 4, then it's 192. And then this is 1, this is 3. Start with 9, then we cannot end with 9 anymore. And then we have the 6 minus 1, then this is 4, 3, 2. Okay, well, first and then the last. Okay, so we have the 4 times 3 times 2 times 3, then is 72. So 192 plus 72, then is 264. Okay, 192 plus 72 is 264. Okay, this is number 3. 264. Question number 6. Find how many different 4-digit number can be formed using 2, 3, 5, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 6. So if each digit may be used only once in any number, so we have the 6p4 here. So this will be the 6p4, then 360. Okay. And then how many of the number found in part 1 are divisible by 5? So 4 digit divisible by 5 and with 5, 1 here. And then out of 6, 6 minus 1, then 5, 4, 3. Okay, 60. Okay, so this is 60. Okay, we can also say that uh, it is the 5p1 here. No, this is the 1p1 here. And then we have the 5p3 here. So 1p1 is actually 1. Okay, 1p1 is 1. So we have the 5p3, then is 60. Yes. Okay, number 3. How many of the number found in part 1 are odd and greater than 7,000? 7, 8, 9. So odd, odd can end with the 3, 5, 7, and 9. So this is odd and greater than 7,000. Okay, so we have the 3, 5, 7, 9, 4. Okay, and then start with 8 here, 1. And then out of the 6 minus 1 minus 1, we have 4, 3 here. Okay, so this will be 4 times 4 times 3, then is 48. And then we have the 3, 5, 7, 9. So 7 or 9. So we use either 7 or 9 to start. And then this will be 4 minus 1, 3. So we have 3 here. So if we start with 7, then we end with 9. If we start with 9, then we end with 7. So we cannot end with. So we start with 7. Then the 3, 5, 7, 9 here cannot use 7 anymore. Start with 9. Then the 3, 5, 7, 9 here cannot use 9 anymore. So we have 3 here. 6 minus 1 minus 1, then is 4, 3. So we have the 2 times 4 times 3 times 3, then is 72. So 72 plus 48, then is 120. Okay. Question number 7. Find how many different 5-digit number can be formed using digit 1, 2, 3, 5, 7, 8, 2, 4, 6, 6 here. Use 1 only in any number 5-digit. So 6p5 here. So we have the 6p5, then 720. How many of this number is not divisible by 5? So divisible by 5. So divisible by 5, then is n with 5. 1 only. Okay. Then we have our 6 minus 1, then 5, 4, 3, 2. Okay. So this is 120. So we have the 720 minus 120, then is 600 here. Okay, how many of the number is even and then greater than 30,000? So even then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Even then that means end with 2 and 8, 2 and 8 here. And then greater than 30,000, greater than 30,000, 2 and 8. So we can have the 3, 5, 7, 3, 5, 7, 3. Then out of 6, we minus 1, then is 4, 3, 2. So we have the 3 times 4 times 3 times 2 times 2. then is 144, and then we can start with 8, and then only we can end with 2. Okay, then out of 6 minus 1 minus 1, okay, then is 4 3 2 24. So we have a 144 plus 24, then is 168. Okay. Question number 8. Find how many different 4-digit number can be formed using 1, 3, 4, 6, 7, and 9. 2, 4, 6, 6 here. 4-digit number. So we have 6p4. So we have the 6p4, then is 360. How many of these 4-digit number are even and then greater than 60,000? 1, 2, 3, 4. 1, 2, 3, 4. Even, then it ends with 4, 6. Okay, so 2. Then out of, and then greater than 60,000, then 7 and 9 here. Then we have 2 here. 6 minus 1, then 4, 3. Okay, so we have 2 times 4 times 3 times 2, then it's 48. And then we have the start with 6 here, then we can end with 4 only. 1, 1. Then 6 minus 1, 4, 3. So this is 12. So we have 48 plus 12, then is 60. Yes. Okay, that 4-digit number are to be formed using 4 of the digit 2, 3, 7, 8, 9. Each digit may be used once only in any 4-digit number. Find how many 4-digit number can be formed if there is no restriction. So 5p4 here. So we have the 5p4 120. So it is even number. Even number 1, 2, 3, 4. Even number and with 2 and 8. Okay, so we have 2 here. 5 minus 1, 4, 3, 2. So we have the 4 times 3 times 2 times 2, then is 48. Okay, and then greater than 7,000 and odd. Okay, greater than 7,000 and odd. So odd and with 379, 3 greater than 7,000, then 8 here. So we have the 6 minus 1, then 4, 3. And then we can have the 7 or 9 here. Then 3, 7, 9 here. We have 2 here, 2 here. And then, okay. Hmm. Then we have the 6 minus 1, then 4 here, 3. Okay, this is because when we use 7 here, then we cannot use 7. If we use 9, start with 9, then we cannot end with 9. Okay, so 2 choice at the starting there, and then 3 choice at the end. So 36, and then 48. And then 48 plus 36, then is 84. Okay, so the answer is 84. Oh, wait, the n here is 5, so this should be 5 minus, no, so okay, um, so 5 minus 2, 3, 2, and then 3, 2. So 24, 18. So we have 24 plus 18, so it's 42. Okay, that.